Hello everyone. So till now we have seen the difference between functional programming language and object oriented programming language. Now we will have a look at the first concept of Java 8, which is Lambda expression. So let's see the syntax of Lambda expression. What exactly is the syntax of Lambda expression? Right. So let's assume for now that we are not dealing with the return type. We will have something like this. Return type. So let's assume this would be the return type. Return type equals function, let's say public and sum and num1 comma and num2. Now we have a function which adds two numbers and returns you the sum of those two numbers, num1 plus num2. Right. So this is a method. Now we can assign this method to one particular variable of a return type, let's say a return type. However, this is not true. Please ignore this part for now. Let's first understand what exactly is the syntax of Lambda expressions, and then we will have a look at what exactly is the return type of this Lambda expressions in Java 8. Okay, so this is a valid method in Java with an access modifier as public, return type as int, sum is the name of the method which has two arguments, int num1 and int num2. Now this method returns the summation of num1 and num2. Now what we are doing in Lambda expression is we are assigning this particular method to one variable. Please note that we are not assigning the result. We are not assigning and result equals to sum 10,5. No, we are not doing this. In this case, we are assigning the result, that would be 15, to this variable. The difference between this and this statement is, the first one we are assigning the entire function to this return type, and in the second type we are assigning just the result. Now let's have a look at the syntax of Lambda expression. We do not need access modifiers in Lambda expression, so we can remove this. Again, Lambda expression is an anonymous function, is very similar to anonymous function, so we do not need a name because we would be using this as a variable name, right? We would be referring this function with this variable name, so why do we need sum over here? Again, Java compiler is smart enough to detect that the return type of this method is an integer. That is why we do not need the return type statement as well, and this hyphen and greater than symbol. This is known as lambda expression. So this is the syntax of lambda expression in Java 8. Please note, this is very important, the syntax of lambda expression. Let's write once again. Syntax would be argument 1, argument 2, lambda expression, and then the body. That's it. Only this is the syntax. However, if we can also remove this int, so we have argument 1 comma argument 2 and the body. That's it. Also, when we have only a single line in the body, we can remove the curly braces as well. So this is valid syntax if we have single line body. We can also remove the round brackets if we have only one argument type. So let's say we have this, then we have only one argument, then we can, and a single line, then we can remove the round brackets and the curly braces as well. Please note, this part is important and we need to have this lambda expression whenever we are writing lambda expression in Java 8. Now let's go and create a simple example so that we can get a good understanding of how to use lambda expressions. Right, so we will create a new class. Let's first create a new interface. I will tell you why. Calculate interface. It will have one method which will return int. Method name is calculate. It has two arguments. One is int num1 comma int num2. We will create a class. Let's call this Java 7 sum demo with the main method, obviously, because we need to execute this function. Yes, so in this function what we will be doing is we will create an implementation of calculate interface, and we will use that and use calculate method to find sum of two numbers. Right, so let's create a class calculate impl. In this class implements calculate, C should be capital, I'm sorry for that. It implements calculate interface. Now we will get a compile time error which will say to add the unimplemented methods. I will remove this comments with Control D on my Windows machine. Let's provide an implementation to this method. We will calculate sum of num1 and num2 by returning num1 plus num2. Now we will create an instance of this class, calculate impl calc equals to new impl, and then calculate dot, we will provide the numbers 10, 5. And we will display this result. We will run the program. We got our output. Sum of two numbers. Let's run once again. Sum of two numbers is 50. Now let's say we want to, so this is type 1 by which we can run this type of example by creating an implementation of an interface. Now we will look at the other type by which we can run same piece of code, but we will be using anonymous inner class rather than using a defined class. Let's see how that example goes. So what I will do is I will just copy this program, anonymous demo. I will change the name, anonymous demo, and we do not need the implementation here, so I will remove this piece of code. Now this is the type 2 where we will create implementation. No, we won't creating an we will be creating an implementation, but we will create anonymous implementation and calculate the sum of two numbers. So how we need to create anonymous inner class? First we will create an instance of that method, and then we will provide the implementation in this anonymous inner class, num1 plus num2. That's it. This is our anonymous inner class, which overrides this method calculate and returns the sum. Let's run this example. Again, the sum of two numbers using anonymous inner class. The sum of two numbers using inner class is 15. So this is working absolutely fine. But this is okay. We want to use lambda expression, isn't it? So let's create an example with lambda expressions. So we will remove the anonymous word and we will change it to Java 8 sum demo. We will also change the name of the class Java 8 sum demo. We will create lambda expression we'll create lambda expression implementation of calculate interface and use the calculate method. Perfect. So now, like I have shown you in this particular example, we need to remove the unwanted code and we will include and we will create the syntax of lambda expression. So what I would suggest is pause the video and try to do it yourself. If not, we will again I will show you how to do it. Okay, so let's remove the unwanted code. We know that this calculate is not necessary because this is a anonymous function. Lambda expression is an anonymous function. So let's remove calculate. Public override is not required. Let's remove this. Now we do not need int because the compiler is smart to find out what would be the return type based on our return statement. Now let's remove the new instance of anonymous inner class. Let's set, and most important thing, include the lambda expression. See, this is the lambda expression. Now, like I have said, we do not need curly braces when we have a single line of code. We can remove this. And we do not need return when we have a single line of code or we are not using the curly braces. We can also remove int right. So let's run this code. Using lambda expression. Is perfect. So we are getting the exact same result with just a single line of code. This is functional programming. We are assigning this particular function to this variable, this return type. So I told you to forget this return type for now. Now we will look what exactly the return type is. Let's go into this declaration of lambda expression. Now lambda, whenever we define a lambda expression, the compiler tries to find a interface with a single method which matches the exact same arguments and the return type, which is happening in this case. So whenever we define this particular syntax, the compiler knows it has to go and check in this calculate interface and that is why the return type is the interface which we have defined. Again, this is a functional interface because it contains only one method. We will have a look at what exactly the functional interface is, but for now let's understand the lambda expression thoroughly. Now let's compare the lines of code of the Java 8 demo and Java 7 demo, which was using anonymous inner class. So this is our anonymous inner class code in which we were declaring an anonymous class with a method calculate with two arguments and the return statement, and this is the code in Java 8. So as you can see, the number of lines of code have reduced drastically. Where we were using close to 5 lines of code, now we are doing the same thing in just one line, exact same functionality. The second advantage is this is functional programming. This is a type of functional programming wherein we can pass we can call a method, let's say display, and we can pass the interface which we have created, and let's say this method will calculate the sum. Or in fact, let's do one thing. See, again the sum of two numbers using lambda expression is 15. We are getting the exact same result, and we are passing this particular function into a function as an argument. This is what functional programming is. So we have a clean code, we have reduced the number of lines of code, and we are performing functional programming in Java using lambda expression. So I will end this particular video, and we will also look at a couple of more examples in by using lambda expression.